I've always been kind of, I don't know, envious of people who can just like whip out a ruler and compass and like, boom, perfect circle or bisect an angle. Like it's like second nature to them. And I'm over here like, struggling with a protractor.
It can feel like they're part of some secret society, right? But in reality, geometry, it's not about like hidden knowledge. It's more about appreciating these elegant principles.
Yeah.
That are kind of like the rules of the game for all the shapes we see around us every day.
Yeah, no, totally. And that's what I'm so pumped about for this deep dive. We're like going all the way back to basics. Rulers, compasses, dividers even, the whole kit and caboodle. I got to admit something. I always thought dividers were like just for old maps, but apparently they're really important for comparing lengths in geometry. Who knew, right?
It's amazing, isn't it? These tools we're talking about, they've been used for centuries. And each one of them has this crucial role in taking these like abstract geometric concepts and making them real, making them tangible. Take the compass, for instance. I mean, the fact that it can create a perfect circle just with a few simple movements, it's not just practical, it's almost poetic, don't you think?
Totally. And to think like civilizations have been using compasses for millennia. I mean, we're talking like ancient temples, modern bridges, you name it. It really makes you appreciate like the power of these simple tools.
It speaks to this very human desire for order, for precision. Circles especially, they've captivated mathematicians, architects, artists, you name it. Think about the Pantheon in Rome. That massive dome, perfectly hemispherical, it's a testament to the ancient Romans' understanding of these geometric principles.
Wow. I never even thought about it like that. But you're right. Like next time I see a circle, I'm going to be thinking about all that hidden precision, all that history behind it. But circles aside, what about those other basic elements like line segments?
Oh, yes. Line segments, the building blocks of so many geometric constructions. It's fascinating, isn't it? How something so deceptively simple, just as a straight line with a beginning and an end, it can be like manipulated, combined to create this infinite variety of shapes.
And yet, like copying a line segment accurately. I mean, without, just eyeballing it, that's where things start to get a little more, I don't know, technical.
Precisely. And that's where that trusty compass and ruler method comes in. Yeah, it might seem a little more involved than just, using a ruler, but that level of precision, that's crucial, especially when you think about how even a tiny error on paper could translate into like a major problem. Like in a building, for example, imagine a bridge where a critical support beam is off by even a fraction of an inch. The consequences, I mean, they could be disastrous.
Yeah, that's a scary thought. It makes you realize how much we rely on the precision of geometry.
Yeah.
Every day. And often without even realizing it.
Exactly. And that brings us to another really important element, perpendicular lines. See, it's not just about the lines themselves, it's about how they relate to each other. That's equally important.
Okay, so like ASCIIs are the building blocks. Perpendiculars are like, I don't know, the scaffolding, the stuff that holds everything together.
Exactly. It's all about stability, structural integrity. Think about the framework of a house, those perpendicular beams, intercepting at perfect right angles.
Yeah.
That's what allows the walls to stand up straight. That's what keeps the roof up. It's all about making sure the whole structure is sound.
Right. You don't really think about it until you see like, I don't know, a house that's like leaning over. And the cool thing is we have like not one, not two, but 3 ways to create these perpendicular lines. The paper folding method. That one always seems so, I don't know, intuitive, like it was revealing some hidden geometry truth or something.
It is a great way to visualize the concept, but for real precision, for adaptability, you can't beat the compass and ruler method. I mean, it's used for everything, from building a simple shed to designing a skyscraper. Being able to create that perfect 90-degree angle, it's indispensable.
It's like the foundation upon which so much is built, literally. And speaking of foundations, angles themselves, I have to admit, I used to think of angles as like just those things you measure with a protractor, acute, obtuse right angle. But there's so much more to it than that, right?
Oh, absolutely. Angles are like the unsung heroes of design, of engineering. They determine the slope of a roof, how effectively it sheds rainwater. They influence the structural integrity of a bridge, its ability to handle stress, weight. Even something as simple as like the angle of a chair back. It can determine how comfortable it is, how ergonomic it is.
It's amazing how something like we often just like don't even think about plays such a big role in our daily lives. And the fact that we can copy angles bisect them even with such precision, using like a compass and a ruler. It's kind of mind-blowing.
It is remarkable, isn't it? The technique for copying an angle. It's a perfect example of how geometry often comes up with these really elegant solutions to what seem like, complicated problems. By carefully transferring arcs, points, we can replicate any angle, and we can do it with incredible accuracy.
It feels like magic, almost. But it's really just about understanding these fundamental principles, and then there's angle bisection, which, I don't know, it always seemed like like a bonus skill, something you'd only need for, like, I don't know, super advanced geometry problems or something. But you're telling me this has real-world uses, too.
Oh, absolutely. Think about, like, designing a symmetrical facade for a building with perfectly mirrored windows, arches, or imagine you need to divide a piece of land into equal portions to make sure that everyone inherits the same amount. Angle bisection, essential for that, and countless other tasks.
Wow. It's like this hidden tool that solves all these practical problems. It definitely makes those geometry lessons feel a lot more, I don't know, relevant. That's for sure. It's wild to think about, right? Like the same principles that people were using to like divide up land hundreds of years ago are still like super relevant today for modern design, engineering, all that.
Yeah.
And speaking of things that have like stood the test of time, like those special angles, the 30s, the 45s, the 60s, the 90s, they always seem to like, I don't know, pop up in the most random places. Like they held some kind of like, I don't know, geometric significance or something.
They do. They absolutely do. These special angles, we call them that for a reason. They're often associated with regular polygons. Those visually pleasing shapes, like equilateral triangles, squares, hexagons. These shapes and the angles that define them, they've been fundamental to architecture, to design. I mean, for millennia, we're talking like from the pyramids of ancient Egypt to like modern geodesic domes.
Oh, wow. Now that you mention it, you do see those shapes everywhere, don't you? Throughout history, across different cultures. There's something like inherently balanced about them, harmonious even.
Exactly. And the 60-degree angle, that one's a real workhorse. You know, it's the angle that gives the hexagon its structural strength. It's why honeycombs can hold so much weight. While using like minimal material, it's also key to understanding the stability of those futuristic looking geodesic domes, the ones that can span like huge areas without needing any internal supports.
Whoa, mind officially blown. I've never made that connection before. Like the humble honeycomb and a geodesic dome sharing a common geometric link. It's like you're revealing, I don't know, some kind of like secret code.
That's the beauty of geometry, isn't it? Once you start to see the patterns, the relationships, the world transforms. It becomes this intricate tapestry of shapes, of angles, all interconnected. And the best part is anyone can learn to appreciate this. Anyone can learn to create these geometric wonders themselves.
I'm not going to lie. I started this deep dive feeling a little, I don't know, intimidated maybe by all this talk of constructions and angles and stuff. But honestly, you've totally inspired me. It's like you've given me this whole new way of seeing the world. One that's like beautiful, but also full of this hidden order.
That's what I was hoping for. Don't just observe the world, right? Explore it through the lens of geometry. Pick up a ruler, a compass. Try some of these constructions yourself. Who knows? You might just surprise yourself.
I love it. And listeners, don't forget to check out our website for all kinds of bonus materials. We've got like step-by-step guides for all the constructions we talked about today. And hey, maybe you'll discover a hidden talent for design. Or maybe you'll just start to notice all the amazing geometry that's all around us every day. Until next time, stay curious out there.